and it seems to me the recorded started. I'm waiting for the confirmation. Yes, I have the confirmation. Fine. And I will now share my screen with you, my tablet. And it seems to me, starting from now, you should see the first screen of the presentation. Please confirm whether you see or not.
Yes, I can see it.
Fine, super, so thank you. Maybe 2 or 3 sentences about the structure of the semester. I know we discussed the structure of the semester when we met on Monday, yeah, but just to recall, to refresh. Semester number 4, 15 weeks in the semester, and what is the structure? Lectures, classes, and labs. Fine, and labs. 1 hour per week of lectures, 2 hours classes, and 1 hour laboratories. Last time, so on Monday this week, we did agree that we will meet all Mondays, starting from the first week to the last week. For the time being, we have classroom number 19, but I would prefer to change the classroom to another one, just to have opportunity to have space or resources to use a computer at the end of the semester. Okay, then Wednesday, like today, lectures starting from 4 p.m. to 5:30 p.m. online, and please note, because there is 1 hour per week, if we start, for example, today and continue week by week, we will finish at the half of the semester. So please remember about this. The proposal was to have lectures week by week by week. So we will continue next week. And if we do so, we will finish, we will complete the lectures in the half of the semester. And this is my understanding of the conclusion from laboratories. And please confirm whether I am right or not. It means whether you have other obligations next Wednesday at that time, or you are free and we can continue week by week. Please confirm or say it is not possible. Anybody?
Hello, sir. Please, can you repeat? I don't understand what you are asking. What are we confirming, sir?
Okay, so we have 1 lecture per week. But if we have lectures like today on Wednesday, starting from 4 and finishing at 5:30, yeah. So now we do 2 hours per 1 week. So if we do so continuously, we will finish lectures in the half of the semester. And my question was, is it possible? Just to confirm, I did understand from the Monday's meeting, it is possible for you to continue Wednesday, 2 hours, week by week.
Sure, I think it's good. It's a good suggestion, I think.
Yes, sir. We already set another date for the lectures, which we should have this time every 2 weeks. We set the term for Monday after our lessons, so yes, we can do 2 hours every Wednesday for half of a semester.
Okay, so it was my point, just to confirm the structure of this semester. Thank you. And the last issue here, Friday classes starting from 2 p.m. and ending at 3:30 p.m. and online. Yeah, so from the first to the last week, we will take classes on Friday. Okay. What is the content of the course during this semester, semester number 4? I put here 4 points that are main from my perspective. So stability criteria for ships carrying grain in bulk, it is for today. The next package of lectures, it will be stability of the grounded vessel. The next package will be stability after flooding of watertight compartments. And the last issue will be stability failures in waves, so-called dynamical stability. So 4 packages for the semester for 15 weeks, structured as we discussed a minute ago. So main packages. We'll start with stability criteria for carriage of grain in bulk, and it is today's topic. Fine. What shall you do to pass the subject? It seems to me it is obvious for everybody. Just to confirm, first of all, you have to listen to attend all lectures, classes online, attend all laboratories in person, and I assume now that laboratories will be on Mondays face-to-face. So if the COVID situation will not change, we'll meet 15 times on Mondays. So you have to attend all laboratories. Then you have to submit all required reports. And from my perspective, on time, it is very important. So if it is a date to submit a report, please do it on time, not to postpone submission of the report. Now, at present, I have not decided how many. It depends on the situation, and I think at least 3. So as during the third semester, but at the moment I am not sure. I would prefer more reports. It is added value for you, not for me. But it seems to me that we have to assume at least 3 at the moment. And the most important, it is that you have to pass the final exam. And probably the final exam will be online, and we will use Moodle platform for this purpose. So you have to attend all laboratories, actually listen to all lectures and classes, be active as much as possible. You have to submit reports on time, at least 3, and you have to pass the final exam. Okay, what else did I prepare? This is the slide taken from previous semester. So what I suggest to do during this semester, first of all, keyword passion. Secondly, be always on time, not to postpone the task to the next week. So, for example, if we take today stability criteria for ships carrying grain in bulk, please be sure this Saturday or the Sunday you do really understand the criteria that are for carriage of grain in bulk. Make your notes. The notes, it is very important to have. If you make notes, you study, you learn at the same time. Do all exercises by your own. For example, like last Monday, if you did your exercises by your own, you have added value. You really understand what is going on. If you just make notes following your colleagues, maybe added value is not so big. Okay, books, it is very important. If you have any book you can read related to our subjects, please do it. 2 examples are shown on the screen. If you don't understand anything, please ask questions. Asking question has at least 2 advantages. First of all, I will answer your question. And secondly, this is also a feedback for me. If you, I'm talking now about a group, not a particular student. If you ask questions, it is also information for me. What should I stress in the future? And of course, you have colleagues, and you can discuss different problems, different issues with your colleagues. Exercise and practice by your own, and in addition to mandatory task. If you feel that you would have added value, if you calculate something by your own, please do it. And the last but not least, do not learn by heart. Don't learn by heart. You know my approach to our subject. We discussed at least a few times. Don't learn by heart. Try to understand the problem. I can remember you told me if you have a formula, you will solve any problem. And then I gave you the formula like that. And we discussed what does it mean. It does mean nothing. If you don't know what does it mean X, what does it mean Y, what does it mean Z, it is at the same time the formula how to calculate trim, TF minus TA. It is at the same time the formula how to calculate writing lever, how to calculate initial metacentric height. It is the same formula for calculation of writing lever. Yeah, still it is something minus something. Okay, the most important is to understand what does it mean X, what does it mean Y, what does it mean Z. I hope you did catch my view. Don't learn by heart. If you know what does it mean trim, the formula how to calculate trim is obvious. Okay, so it was my hint, and I did actually I reminded because we discussed the same slide starting semester number 3. Okay. So let us start with the problem, with the task. Now I show you Regulation 20. This is Regulation 20 taken from SOLAS Convention. And you should remember it, not necessarily word by word, not necessarily wording, but idea which is hidden behind this regulation. The master, it means you. It is my first keyword here. And in my opinion, from the perspective of today's lecture, the ship is in compliance with stability criteria in relevant regulations. And I would highlight relevant regulations for the purpose of this lecture. What does it mean the stability is correct? It means that you can calculation, you can ascertain by numbers, it is very important, by numbers, that stability criteria are satisfied. The ship is in compliance with stability criteria in relevant regulations. So this is also something what I wanted to stress and remind. The next thing I wanted to remind from the last semester number 3, is the question, what does it mean stability from our perspective, at least from today's perspective. And the definition I invented of stability for our purpose. Stability, what does it mean? It means compliance with stability regulations. The ship is stable, the ship is safe. Maybe I should say the ship is supposed to be safe. The ship is supposed to be safe, prior to departure, of course, if the ship, the loading condition, the shape of the hull is in compliance with stability regulations. What is regulation? What is the structure of such a regulation from our perspective? We have a criterion, we have a standard, and the regulation is proper relationship between the criterion you calculate, this is the result of calculations, and a standard which I would say separates ships that are supposed to be safe from ships that are supposed not to be safe. Criteria, that are parameters you can calculate, describing ship stability. Yeah? Criteria, parameters describing ship stability. And probably you remember I assigned to you last time task number 3, and you were expected to describe different criteria taken from relevant regulations, and I hope you can remember what regulations I'm talking about. Now I turn to a group who is the first on my list. The first is Robert Kipkacz. Robert, can you hear me? Robert Kipkacz. Please say something.
We can hear you, sir.
Yes, fine. The question goes to you, just to make sure everybody understands the structure. Could you please name any criterion taken from the previous semester? Can you name a criterion? What does it mean, criterion here? Just to check whether everybody understands what does it mean, criterion in this structure. Could you name a criterion? Any?
So, one of the criterions is area under GZ's curve between 0 degrees to 30 degrees. Then the standard is that the area should be greater than or equal to 0.055 meter radian.
Very good. Yeah. So now you told everybody, assuming that maybe there is a student who didn't catch the point, what does it mean criterion in this structure, and what does it mean standard? Very good. Thank you very much for doing this. Criterion, for example, area under GZ curve, and the standard is, like you said, 0.055 meter radian. This is understanding of this structure. Okay, assumptions for calculation, method of calculation. I hope you do understand at the same time what does it mean assumption, what does it mean method. For example, defining GZ curve, defining writing lever, we did assume that there are only two forces acting on the ship, weight and displacement. It was the first assumption we've made during the third semester. This is kind of assumption. For example, we did assume that if you calculate GZ curve, you have at the same time, previously actually, calculate vertical position of the center of gravity, kg, and you have to multiply it by sinus of the angle of heel, okay? What I'm thinking about now, one of the assumptions is that the vertical position of the center of gravity takes into account free surface correction. Free surface correction we calculated and discussed during Monday's laboratories. So, for example, this is the next assumption for the calculation. If you want to take into account the phenomenon related to free surface, to liquids in partly filled tanks, we may assume that this phenomenon is described by so-called free surface correction. I would recall the discussion, what does it mean, inertia moment of a surface, and so on. Method of calculation, if you calculate area under GZ curve, actually during last semester we used trapezoidal method for this purpose, yeah? Okay, and now the question goes to somebody else, and I turn my tablet to the group, to Teams. MN, it is, I'm not sure, Mario Nutz. Mario, you are the second on my list. Could you please explain what does it mean documentation in this meaning, area under GZ curve? If you want to calculate area under GZ curve, under writing lever curve, what documentation shall you use for calculations? Mario, can you answer such question?
Is it hydrostatic tables, loading plan, and that's it, probably the main things.
And probably you will not calculate writing lever curve if you have no
cross ještě.
Cross curves, yeah. This is data for your calculations. So when I put here a rectangle documentation used for calculations, I meant hydrostatic table, as you said, and cross curves. And you mentioned about other pieces of documentation like loading plan and so on, and you were correct. Loading plan or tank scaling, hold scaling, anything that helps you, assists you to calculate, for example, position of the center of gravity. Fine. Very good. So it is refreshment of the last semester. Fine. I hope everybody is in. Everybody understands this structure. And what next? Now I copied for you the content, actually part A, the content of the 2008 IS code. 2008 IS code. So I hope when I read this regulation number 20 and I stressed criteria in relevant regulations, I hope that you thought that probably relevant regulations, it is 2008 IS code, intact stability code, international code on intact stability of ships. Okay, and I put here the content. This number, resolution number MSC.267, this is the number of resolution containing the code. Please confirm, I am not sure at the moment, please confirm you can read words on the screen. Are the
Yes, sir.
Yes, letters big enough to read? Okay.
Yes,
So,
they are.
Super. Thank you. Okay, so content of the 2008 IS code, general criteria, fine, chapter number 2. Chapter number 1, it is general statements like application, information about the dynamical stability phenomena in waves. If you follow me, waves and dynamical phenomena, this is the last issue we take on board during this semester. Okay, so we'll come back to this probably in May or June. Fine. Criteria regarding writing lever curve properties. It was what we have done. And if I remember Robert correctly, Robert told us about this criterion, area under GZ curve, and the standard, he said correctly, it was 0.055. Okay, so criteria regarding writing lever curve properties, and from my perspective, it is done during the last semester. But, and now I change color to green. There are special criteria for certain types of ships contained in chapter number 3. So chapter number 2, general criteria, applicable for all types of ships, and there are special criteria for certain types of ships. And if I remember correctly, last semester we discussed passenger ships criteria. There was angle of heel caused by passengers crowding on one side, and there was angle of heel for ship in turn, and probably abbreviation here was FIR. So two criteria related to passenger ships. You can see the list. The list consists of 5 types of ships: oil tankers, cargo ships carrying timber deck cargoes, and 3.4 cargo ships carrying grain in bulk. Cargo ships carrying grain in bulk. So this is the problem for today. Special criteria for certain types of ships, and we focus today on cargo ships carrying grain in bulk. Grain in bulk. Chapter 3 and paragraph 3.4. Cargo ships carrying grain in bulk. Now I will stop for a moment and ask the question. Now I turn to the group. Here at home I changed tablet from the presentation to Teams, and I turn to the group with the question, did you catch the point? Do you understand correctly where we are now? If you have question, please ask a question. I tried to follow to some extent knowledge from semester number 3, to summarize it from main point, and now I'm intending to open new chapter, criteria for grain in bulk. But before I do it, please tell me whether you understand the point or you have question, just to be sure we are on the same footing. No questions?
Yes, sir. We catch the point about angle of fuel caused by crowding of passengers and angle of fuel when the ship is turning. I think we all catch the point, sir.
So I'm not sure if I understand you correctly. So you confirm that you are so that you understand where we are now. Am I right?
Yes, sir.
Yeah. Okay. So now we open new chapter. We open chapter, criteria for ships carrying grain in bulk. And if you open the code, 2008 IS code, intact stability code, you will find that the paragraph number 3.4, cargo ships carrying grain in bulk, is very short. Just one sentence. The intact stability of ships engaged in the carriage of grain shall comply with the requirements of the International Code for the Safe Carriage of Grain in Bulk, adopted by resolution, and here you can see the number of the resolution. So if you want to learn, if you want to study stability requirements for ships carrying grain in bulk, you should turn to International Code for Safe Carriage of Grain in Bulk, adopted by MSC. Do you understand abbreviation MSC? What does it mean? And the number of the document is 23/59. Do you understand MSC, this abbreviation? This is a question to you.
No, sir, I don't. Please, what is
No.
MSC?
It is maritime.
Maritime Stability Code.
Yeah, safety.
Safety. Okay.
So, me. T. Okay. I'm not sure it is correct in English. Double T or one T. Okay, it doesn't matter. It is not so important now. Maritime Safety Committee. So this is the committee of International Maritime Organization. International Maritime Organization consists of a number of different committees. One of them is Maritime Safety Committee, MSC, and this is the number of the resolution developed by Maritime Safety Committee. So this abbreviation, this is related to the structure of International Maritime Organization. Information, who did it? Who did it? Maritime Safety Committee. Okay. If I remember correctly, I am not sure, it seems to me the year when it entered into force, it was 1991. But at the moment, I am not sure, so I will put here a question mark. If you wish, you can check it somewhere in your resources. It seems to me that the date of entry into force of this resolution, Maritime Safety Committee resolution, it was 1991. So it means 30 years ago, am I right? Even 30 years ago. So it is rather old one, yeah, rather old resolution. Fine, but still exists and still is in force. And it seems to me that I could stop the lesson just asking you to take this resolution and read what stability criteria are contained in this resolution. But I will not do it. I will show you what is the problem and how the problem has been solved. What is the problem? The problem is very simple. If you have grain cargo in a hold, I'm trying now to show a hold. For example, it will be double bottom here, central line, keel, baseline, okay. And I change color to yellow. I will fill in the hold with the grain cargo. The hold is filled in with grain, and the hold is partly filled. The grain is partly, the hold is partly filled. And what is phenomenon? What is phenomenon? That we have to take into account. After some time, let's say 2 weeks of sailing, the surface of such a grain in bulk in a hold will change position, and the new position will be like that. New position will be like that. The grain shifts from one side to another side. It takes some time during journey. I told you, for example, after 2 weeks. After some time, even if the grain cargo in hold is trimmed, the surface of the grain cargo is parallel to the baseline on departure. Even if so, after some time, a volume of grain cargo changes position. The grain cargo shifts from one side to another side. Can you imagine such a phenomenon? It is important at this stage that you can imagine such a phenomenon. Your departure, you start your voyage with level of the grain cargo, with surface is parallel to the baseline. You did load the hold evenly with grain cargo, but after some time, due to wave action, due to vibration of the hull, and so on, due to the accelerations of movements, different accelerations, angular, linear, some amount of grain cargo changes position. Cargo shifts from one side to another side. And this is the phenomenon. The grain cargo shifts from one side to another. And this phenomenon shall be taken into account if you assess whether your ship is safe or not from stability point of view. It is very important to take this phenomenon into account. Okay. And what parameter describes the phenomenon? They, it means Maritime Safety Committee, MSC, they introduced a new parameter, which is called volumetric healing moment. Volumetric healing moment. And volumetric healing moment, this is the number that describes how much cargo can shift on what distance. And the distance will be here d. The center of gravity of this part of cargo on departure is here, initial, and the center of gravity of the same amount of grain cargo after some time, after shifting, is here. Here is 1, initial, here is the second, final. So d here, it is the distance between initial center of gravity and final center of gravity of this part of cargo, grain cargo, that shifted from one side to another. So coming back to the formula, VHM, sorry, I told in Polish, VHM, sorry for that, VHM, it is delta V, so volume of the cargo that shifts from one side to another side, times d, times the distance, so-called volumetric healing moment. VHM, volumetric healing moment. The answer on the question, how much volume, how much cargo shifts from initial to final position. How much? For example, I don't know, 500 cubic meters on the distance, let's say 7 meters. Yeah, this is the information contained in such a number, like what volume may be shifted in assumed conditions and on what distance. Volume and distance, volumetric healing moment. And of course, for calculation of such volumetric healing moment, you have to assume the conditions, in assumed conditions. Assumed conditions means, for example, what will be angle here between initial and the final surface of grain cargo in a hold. It is one of the assumptions. If I remember correctly, the grain code, International Code for the Safe Carriage of Grain in Bulk, assumes for partly filled compartment that it will be 25 degrees. 25 degrees, it is assumption. What is the angle between even level and after shifting? This is example of assumed conditions for calculations of volumetric healing moment, VHM. How much cargo taken in cubic meters may be shifted in assumed conditions on what distance? What distance, it means where was the initial center of gravity of the package of grain and where is the final position of the center of gravity of the same package of grain, but after shifting. Now the question goes to the group. How do you think? Who calculates volumetric healing moment and when?
Sure, and excuse me.
Yes.
Don't we need to stop the recording for a moment?
To make two pieces.
Yeah,
of
I don't know if it's needed, but as we used to do in previous semester.
Yeah. I can remember. I propose not to stop. If you need a break, just tell me so I can.
No,
do the
I
break.
just asked if you can stop so the recording can be saved.
Yes, the size of the recording will be bigger, twice bigger, but I think it is a question, shall I put it on the Moodle platform, or maybe it is better to keep this recording on the Teams, because at the same time you can listen to this recording using only Teams platform. And I think I will do in both ways. So it will be available. I am talking now about recording. The recording will be available both on Teams platform and at the same time on Moodle platform, and in one package. Yeah, not divided into two. It is not so.
Okay, sure. Great.
Convenient for me. For me, it is not so convenient, but maybe it is more convenient for students to have just one recording. But anyway, thank you for this.
On Teams, our recordings are only for 30 days, so putting it on Moodle is also a good idea.
Yeah, so this is the reason why I told you I will use both platforms. Yeah, Moodle and Teams. Okay, but coming back to the business, I asked the question. Maybe you can invent. If we have a hold, we know the breadth of the ship, the length of the hold. We know structure of the hold. For example, there is wind tank here, like we told last time at the laboratories. Yeah, so let us assume here is a wing tank. Okay, so the structure, construction, geometry of the hold is known. So my question is, how do you think? Who will calculate volumetric healing moment if the geometry of the hold is known and assumed conditions are known? Assumed conditions are known from the grain code, So I think the answer on such a question is obvious for you, but I would like to listen to your answer. Who would like to answer the question? Who and when calculates volumetric healing moments? How do you think?
Sir, I think it's done by architects that build the ship, like by this department.
Yes, very good. Very good. So volumetric healing moment for particular hold in particular ship, and depending at the same time on the level of the grain, height of the cargo in a hold. I will put here H, the abbreviation of this. Volumetric healing moment will be calculated by the designer. So actually, I would say by the shipyard. Shipyard, but in the meaning design office. So if they design the ship, I'm thinking about shipyard in particular, design office, they know geometry of the hold, they know assumptions for calculations taken from grain code, they have procedures, method, and so on. They do calculate volumetric healing moment for each hold, and the results of calculation are provided in the information on stability for the master. Now I show you on the next slide one page number 36, addendum to trim and stability booklet, part 1. This addendum you may take from Moodle platform, because I put this addendum on the Moodle platform during the last semester. And you can see the page number 36 presents volumetric healing moments for grain, and 25,111. This is position of the bulkheads. Okay, here for example, because that ship has movable bulkheads. The bulkheads you can move. So this is position of the bulkheads, the frame number 25. This is starting point, for example here, 25, and the next bulkhead here is frame number 111. So space, which is limited by bulkheads, is like that. And for such space, they calculated. Maybe I will change color, because I did use yellow as a grain cargo, and I will leave the hold field partly. Let's say 65%. So the level of the cargo in a hold is like that. Height, I will put H here. This is the distance between the tank top, double bottom, and the level of the cargo in the hold. This is H. Fine. 111, this is for bulkhead. 25, it is aft bulkhead on our ship. And the table developed by the shipyard, it was very good answer, developed by the shipyard, by naval architects, calculated, contains the information about different particulars of the hold. And height, it is the first one, height. For example, height is, let's say, 5 meters. Yeah. The next information is ullage. Batuhan, can you answer the question, what does it mean ullage here? I change color to red. if h is height of the cargo above the tank top, what could be Ulasz? Which distance? Batuhan, do you know?
I try to remember, so I'm not sure. But if the attached, the ullage probably means the distance from the top of the vessel from the bottom of the tank.
Ullage, this is
Yes.
the distance between deck and the surface of the cargo.
The cargo, yes. Yes, that's right.
So it will be Ullage. I will put here letter U. So if we add H and U, we should have the height of the hold. Am I right?
Yes.
Yes.
Yes, sir, exactly.
Yeah. Okay. So the sum of two numbers shall be the
More or
same,
less equal.
constant. Yeah,
Yes.
shall be constant.
Yes,
Mhm.
yes.
So h, height, this is the distance from double bottom to the bottom of the hold, actually, to the surface of the cargo. Ullage, this is the distance from the surface of the cargo to deck. Okay. Who answers the question, what does it mean G fall here? How do you think? G4, this
Is it
column.
the volume of the cargo then?
Yes, this is the volume, very good. So this is fall volume. They put here G. I think the letter G stays here as a grain volume, yeah, grain volume. So this is a volume. How many cubic meters of the grain is contained in the hold if the hold is filled in to particular height? Okay. For example, I suggested number 5. So if the hold is filled in with grain cargo to 5 meters above the tank top, the double bottom, it means that the volume of the grain is 2,847.5 cubic meters. Yeah, this number here. Okay, the next number, CGX, CGZ. How do you think? What information is contained in these two numbers?
That's the distance in the X and in the Z axis from the center of gravity.
Of the cargo.
Yes.
So this is the distance, CGX, and probably the distance CGZ. Yeah?
Yes, exactly.
Center of gravity of the grain in the hold if the height of the cargo from double bottom is 5 meters. So 3388, this is X dimension, longitudinal, and 3.74, this is vertical. Yeah? So this is information here. And G, R, and V, this is the same as volumetric healing moment. Here they called it grain. R, I don't know what does it mean. R, I don't know. GR, it is grain probably. GR, probably it is grain. M stays here as moment and V as volumetric. So the
Maybe
abbreviation,
it's the writing moment volumetric.
no, for sure it is not writing.
Okay.
Actually, it should be healing moment. If the ship, if the situation, the phenomenon is like that, it is rather healing moment than writing. Do you agree? You should. Yeah. If the cargo shifts from one side to another, it creates healing moment. Am I right?
Yes, sir.
Yeah. Okay. So probably in this particular documentation, GR means grain, M probably means moment, and V probably means volumetric. Okay, volumetric healing moment, GRMV. And the last column is very interesting. The last column, so here it is volumetric healing moment multiplied by 1.12, and it is called here 12%. What does it mean? During if you observe the situation here, probably you noted that I took into account transverse shifting of the center of gravity. Transverse, it means letter D here. But if we take actual situation, the center of gravity, after shifting, moved at the same time transversely and vertically. Can you see this? Here is D, and I put here delta Z as vertical shifting of the cargo. D could be like delta Y and delta Z. Please focus for the moment on the green area here. If part of the grain cargo shifted from one side to another side, the center of gravity moved transversely, D, delta Y, if we call this, it is axis Y, but at the same time, the volume shifted vertically, and I put here delta Z. And in stability calculations, they assume that if you, it is assumption, it is very important to note, this is assumption. They assume that if we multiply volumetric healing moment calculated only transversely, if we multiply it by 1.12, so increment of 12%, the phenomenon of vertical shifting will be taken into account. So the shipyard does not calculate vertical change, vertical distance of shifting of the center of gravity. They assume that if they calculate volumetric healing moment in transverse direction and multiply it by 1.12%, the phenomenon of vertical shifting will be taken into account. This is assumed condition, and this is assumed situation. So actually, they calculate only transverse shifting of the center of gravity, D, and then to take into account vertical shifting, they multiply the result of previous calculations, of transverse calculations. They increase this result by 12%. So this is the reason, and this is the meaning of the column GRMV, grain moment vertical, increased by 12%. The vertical shifting of the center of gravity is taken into account. Okay, so for your calculations in the future, you should use this column. Not only vertical taken into account, but also at the same time, not only transverse shifting, but at the same time vertical shifting. To simplify calculations, they assume that vertical shifting increases the moment by 12%. Okay. So I tried to explain the phenomenon. Okay. To describe this phenomenon, shifting of the cargo, they calculate volumetric healing moment. It means shipyard. Okay. So they answer the question, how much volume shifts on what distance? And then they multiply it by 1.12 to take into account that at the same time the grain cargo shifts vertically. And you, as future master, have so-called volumetric healing moment for particular hold given in ship documentation. In our case, in our example, this documentation is called Addendum to Trim and Stability Booklet and Part 1. You can find volumetric healing moments as a data for your calculations in stability booklets, actually in addendum to stability booklet. So the number in ship operation is known for you. The number is function of the height of the cargo above the double bottom, above the tank top. Data for calculations. Phenomenon and the number that describes the phenomenon. The number given in stability booklet. The shipyard calculates it for you and provides result of the calculations in the form of the table. It seems to me if I wanted to put the same information in the form of the figure could be like that. This could be H in meters. This could be volumetric healing moment in meters to force power. Okay, and here is minimum, so 0, no cargo, and let's say here's maximum. Maximum, it means the hold is filled in 100%. It seems to me that if we want to see the curve could be like that. It is my imagination of the curve, the function that describes volumetric healing moment in relation to filling of the hold. It seems to me if we put numbers into, let's say, Excel format, the result will be something like that. The maximum of volumetric healing moment is somewhere close to 50% of the filling of the hold. You can see this is that range here, more or less the same. Okay. I am looking at the clock, 20 minutes in front of us, so I have to turn now to the criteria, because I explained the phenomenon, I explained the source of data for calculations, but now probably I have to focus on criteria. What criteria are used for stability assessment if the ship carries grain in bulk? Now, the quality of letters is worse than usually, but I wanted to show you wording just as it is in the code. So I just took grain code and I copied for you parts of such grain code. If you read grain code, as I show you previously, you will find chapter number 7, stability requirements. And now let us read Let us read slowly stability requirements during carriage of grain in bulk. Before I start doing so, I have a question. Please confirm, can you read the text? Is it possible to you to read the text?
Yes, sir.
Fine,
Yes, sir.
thank you. Yeah. Okay, so very fine. Intact stability characteristics of any ship carrying bulk grain shall be shown to meet throughout the voyage at least the following criteria. After taking into account in the manner described in part B of this code and in figure A7. A7, this is the figure here, A7, the healing moments due to grain shift. So a healing moment exists, yeah? It causes healing of the ship, yeah? And what are the criteria? First criteria is the angle of heel. It should not be surprising due to shift of grain. The angle of heel due to shift of grain not be greater than 12 degrees, or in the case of ships constructed after 1st January 1994, the angle at which the deck edge is immersed. So deck edge immersion, whichever is less, whichever is lesser. In general, for ships with I would say good freeboards, usually number 12 is the criterion here. 12 degrees of heel usually does not immerse the deck edge. But if the angle of deck edge immersion is lesser than 12 degrees, this angle shall be taken into account. But in general, from practical point of view, 12 degrees, this is the standard here. This is the standard. So the first criterion, this is the angle of heel, which is caused by shifting of the grain. And the healing moment will be described by the volumetric healing moment. This is the first criterion, angle of heel. Maybe it would be fine if I change color to yellow. Okay, the first criterion is angle of heel, which is caused by shifting of the grain, like I showed you on this slide. The second criterion, let us look for keywords. Area between the healing arm curve and the writing arm curve up to the angle of heel. I will change color. Up to the angle of heel of maximum difference between the ordinates of the two curves, or 40 degrees, or the angle of flooding, Okay, change color. Let's say it will be this angle of flooding. Whichever is the least. So the second criterion here is area between healing arm curve and the writing arm curve, and you have calculate this area from the equilibrium position up to the minimum of the angle where the maximum difference exists between the ordinates, or 40 degrees, or the angle of flooding. If we consider average ship, usually 40 degrees, this is the limit here. So if I turn to A7, it means figure A7, taken from the grain code. Area we are talking about, this is just area which is shown here. Usually usually we start from the point of equilibrium between healing arm. Here is healing arm curve, healing, and writing. And writing. We have two curves. Writing arm curve. I hope everybody can calculate this curve. And the second one, maybe I change the color to green. It is healing curve, healing arm curve, sorry, and area between, limited by angle of equilibrium and the least angle, which is taken from 3. When the difference between the ordinates is maximum, probably in our case this is that angle here. Here is maximum difference between the ordinates, writing and healing curve, or 40 degrees, or angle of flooding. Usually for average ship, angle of flooding is bigger than 40 degrees. But if you have a special ship, and such case that flooding angle is lower, smaller than 40 degrees, we have to limit our area using flooding angle. Okay, so the second criterion number 2 is area between two curves, writing arm curve and healing arm curve. Okay, and the last criterion, change color to green. The third criterion is initial metacentric height. Initial metacentric height after correction for the free surface. I will underline correction for the free surface. Shall not be less than 0.30 meters, 30 centimeters. Okay, so this is the last criterion. To sum up, what stability criteria are applied for grain, for carriage of grain in bulk? Two additional to those we spoke about last semester number 3. The first criterion is angle of heel. The second criterion is area. And the last one is initial metacentric height. Okay. I didn't say about criterion with regard to area. The standard here is 0.75 meter radians. Okay, I didn't say, so now I'm back to this criterion. If you calculate area between writing and healing curves, starting from point of equilibrium and ending, let's say, 40 degrees, the result of your calculations shall be not less than 0.075 meter radians. Okay. Paragraphs 7.2 and 7.3, I think they are obvious to everybody. Maybe I will show you keywords here. The master, as usual. Master, it means you in the future. You shall. What is your responsibility? Demonstrate. You shall demonstrate the ability of the ship at all stages of any voyage comply with the stability criteria required by this section. This section, I understand, section number 7, so namely paragraph 7.1. And when shall you do it? Before loading. Maybe it is good idea to change color and to highlight if you are expected to demonstrate ability of the ship to comply with stability criteria. It means angle of heel, it means area, and it means initial metacentric height, you have to demonstrate this before loading. Master, it means you. When shall you do it? Before loading. And what shall you do? You have to demonstrate ability of the ship at all stages of any voyage you will commence to comply with stability criteria. Comply with stability criteria, it means after your calculations, you demonstrate that angle of heel is less than phi grain is less than 12 degrees, area is bigger than 0.075, okay, and initial metacentric height is bigger than 0.3. Initial metacentric height, this is the distance between metacentric point and the center of gravity, corrected for free surface effect. And the last information today, how to calculate heeling curve. Okay, so I did put the same information as at previous slides, taken from grain code, but a little bit bigger. And I hope you are able to read the text. They did define two additional numbers. The number which is called here lambda O, lambda 0, and lambda 40. Lambda 0, this is the result of such calculations. Volumetric heeling moment, VHM, divided by stowage factor, and divided by displacement. Volumetric heeling moment divided by stowage factor and divided by displacement. Maybe I will delete this and I will put the same text somewhere here. It was volumetric heeling moment divided by stowage factor and divided by displacement. And I will assume now there is more than one hold. So I will put here summation. I here stays as number of holes that are loaded with grain in bulk. Lambda O, this is so-called heeling lever. And this is calculated for the ship in upright position. This is the distance here. And then they assume that the heeling lever calculated for 40 degrees, here is 40 degrees, it is 0.8 of the heeling lever, which has been calculated for the upright position. So this is the method of calculation of the heeling arm curve. I hope you can read here heeling arm curve due to transverse grain shifting. Okay, maybe approximated, maybe represented by the straight line which is from A to B. And points A and B are calculated as follows. A, it is lambda O, lambda 0. B, it is so-called lambda 40. And lambda 40 is 80% of lambda 0. How to calculate lambda 0? Actually, this is volumetric heeling moment divided by stowage factor and divided by displacement. In my opinion, you should read here as heeling lever. It is heeling moment divided by displacement. We use this formula during the third semester. If you want to calculate healing lever, you have to divide healing moment by displacement. Maybe you remember something like that. LW, wind healing lever, it was pressure, area, arm divided by displacement. Okay, so this is the same. Here is general formula. This is application for wind, and this is application here for grain. If we divide volumetric healing moment by Stowage factor, actually it is healing moment. It is healing moment. And the definition of Stowage factor is put here. This is volume of our cargo per unit weight of grain cargo. So actually Stowage factor, this is 1 over specific weight. 1 over specific weight. Okay, so it is the definition. This is the definition of the curve. Actually, this is straight line that represents healing arm. This line here, green color, now represents healing arm. Represents healing arm. So healing arm calculated using volumetric healing moment, writing arm, and area which is limited by writing and lever arms, and angle of 40 degrees or angle of flooding or angle of maximum distance between curves, whichever is the least. Usually for average ship 40 degrees is the least, so they put 40 degrees here. And I turn now to the next information. If the number of holes is bigger than 1, you have to sum up all holes starting from the first one and ending to the last one. VHM, volumetric healing moment, may be found in ship documentation as a function of height of the level of cargo in a hold, in particular hold. So this number is from ship documentation. Stowage factor is given as a description of the cargo of this grain you intend to load, and displacement, that is just displacement. Sum of all weights loaded on the ship, including light ship weight, empty ship weight. Okay, I think I concluded. And now I turn to group. Whether you manage to catch the point and understand the phenomenon, first of all, and the method how ship operation deals with the phenomenon. They decided to introduce additional factor, additional number that describes the phenomenon, and they decided to introduce 3 additional criteria. Actually, the set of criteria is the same as previously for any other ship, but the method of calculations is a little bit different. A little bit different, it means the healing curve, actually healing line, because it is in fact straight line. The healing line is taken into account in such a manner. In my opinion, it is a little bit similar to the weather criterion, if you remember LW1, LW2, and area B. So it is more or less the same. But the factor healing the ship is different, so the method of calculation is a little bit different, and the criteria are a little bit different. Two criteria. The first one is angle of heel, angle of equilibrium, Fiji, grain, and the second criterion is area under curve. Actually, between two curves, healing and righting. Two additional criteria you have to calculate prior to departure, and the third one is GM, initial metacentric height. Package of three additional criteria. Angle of heel, the second area, and the third initial metacentric height. And the method of calculation of equilibrium, angle of heel, and the method of calculation of area. And probably on Friday we'll try to calculate something using numbers, not only general information but also numbers. And now I turn to group before I stop recording, whether at this stage I need to add something or maybe everything is clear for you. I turn to the group, whether you have additional questions before I stop.
Hello, sir.
Hello, God's power, probably it's you.
Yes, sir, it's me. It's clear, though the explanation and the drawing and everything. I think it's very clear. Just that to cram those criteria, like the details, to cram it about each of those points. I think that's maybe what would be hard, but it's the general point is understandable. I think so. Just
fine.
To take note of the criteria, that's just the point.
So I think if anybody has, how to say, is not sure how to calculate, maybe a good idea to take numbers on board on Friday in frame of classes and just calculate angle of heel, area and initial metacentric height, taking into account particular loading condition and particular ship. Was it your point, God's power?
Yes, sir. Yes, sir.
No, fine. Okay, so let us be prepared for calculations on Friday. And on Monday during labs, maybe I will show you pieces of ship documentation just to make sure not to be afraid how to look for numbers for calculations. Anybody else? We are 3 minutes after time, so we shall to complete. Okay, if you have any question, please ask the question on Friday before we start calculations. For today, that's all. So what shall I do? I will take attendance list. I did it. Fine. And I will stop recording. I did it.